Your FastMCP server is doing the same work repeatedly, listing tools, fetching resources, and processing identical prompts, while your users wait for responses that could be instant. We'll implement persistent disk-based caching that survives server restarts, using just 3 lines of code to store and retrieve responses for tools, resources, and prompts with configurable time-to-live settings.
From FastMCP server middleware caching, import ResponseCachingMiddleware. From key value, AO stores, disk import DiskStore. MCP, add middleware, ResponseCachingMiddleware. Cache storage equals DiskStore, directory equals cache.
This demonstrates the middleware pipeline pattern applied to model context protocol servers. Middleware acts as a chain of interceptors that wrap core server functionality, allowing you to inject cross-cutting concerns like caching, logging, or authentication without modifying the underlying components. The distinctive aspect here is the declarative composition. You assemble behavior by stacking middleware layers rather than embedding logic in tools or resources. The pattern works by creating a processing pipeline where each middleware can inspect, modify, or short-circuit requests and responses. Each layer receives the context object, performs its operation, then either continues the chain or returns early. This creates a clean separation between domain logic, your tool's resources, and infrastructure concerns, caching, rate limiting, while maintaining a consistent interface for all operations. This approach solves the problem of scattered infrastructure code by centralizing common concerns in reusable components. You gain consistent behavior across all endpoints without repetitive code in each tool, while keeping your core logic clean. The trade-off is slightly increased complexity in debugging middleware interactions, but the benefits in maintainability and consistency typically outweigh this cost for production systems. Let's break it down line by line.
From FastMCP server middleware caching, import ResponseCachingMiddleware.
This imports ResponseCachingMiddleware, a FastMCP component that intercepts responses to cache them. It eliminates redundant processing for identical requests, dramatically improving performance for repeated calls.
From key value, AO stores, disk import DiskStore.
This imports DiskStore, a persistent key-value storage backend that writes to disk. It provides durable caching for the response middleware, ensuring cached data survives server restarts.
MCP, add middleware, ResponseCachingMiddleware.
This registers response caching middleware in the FastMCP server pipeline. Middleware intercepts requests globally, and this specific implementation caches responses to eliminate redundant processing for identical requests.
Cache storage equals DiskStore, directory equals cache.
This configures persistent caching to disk, storing responses in a cache directory. DiskStore handles serialization and file management automatically, eliminating the need for manual cache invalidation. Critical for production where in-memory caching would lose data on restarts. Closing parenthesis for the middleware configuration. This finalizes the ResponseCachingMiddleware instantiation and passes it to MCP, add middleware, completing the cache setup with disk storage. Caching middleware pattern. The ResponseCachingMiddleware transforms transient responses into persistent artifacts, bridging ephemeral computation with durable storage through pluggable backends like DiskStore or ResponseCachingMiddleware. Cache keys for list operations are global by default, so shared storage backends require explicit namespacing to prevent collisions between services. Configure TTLs per operation type to balance freshness and performance without manual invalidation logic.
The cache that remembers everything forgets to ask what should be forgotten.